from 20 years, something like several billion, I think it was 3.5 billion monthly loan data points. This is what we know about this person with this, it's a mortgage loan. This is whether they defaulted, this is whether they were 1 or 2 or 3 months late. And they trained a network, and they wanted, you want to predict delinquency or prepayment, that you're going to pay it and get a different loan. And so on this graph here is the actual observed number of prepayments versus the predicted number by the model. And the black line, 45 degrees, is ground truth. That's a perfect model. And the blue deep learning model, you can see, is just hugging the ground truth. The red is a more basic machine learning logistic regression, linear regression model. And you can see it's not nearly as accurate. So that is cash money for companies whose core competence is to understand the risk of lending. Insurance companies are all over this, because what is an insurance company? Their cost of goods sold of their product is guessing how much they're going to pay out statistically to their customers. That's their cost of goods sold. So, I mean, that's, we call that underwriting, but it's predictive analytics. So, for example, if you're an insurance company and you want to issue crop insurance, they can take satellite data. Of course, they can say this is their field and this is their crops, but more importantly, they can take historical crop yield, weather patterns, and by using supervised learning with the labeled historical crop yield data, they can do a model that will basically predict how much you would expect to pay out for a given crop insurance. And insurance is very elastic. So if you can hit your target margin, but lower your cost by 10%, and still hit your target margin, you might get 50% more business in a certain segment. So this is absolutely revolutionizing all kinds of industries. I'll go through this one quickly. Quant Investment. Investment banks and hedge funds are going crazy. They build things called factor models, which try to predict what short and long-term factors will predict the return of a security. And now the whole world is your factor model. You can take external data, open data from the internet, but things that might be hidden. You can do speech detection on earnings calls and get the answer in a second, not the next day. There are companies that are selling proprietary data feeds to map the Earth every 15 minutes at a sub-meter resolution. It means you can track, in principle, the location of every tanker, every ship on the planet. Quandl is doing all kinds of receipts, and so you can predict the behavior that correlates to stock returns of, for example, retail businesses. So that's a huge thing. Semiconductor industry, it's obvious that you can do things like defect detection, again, using image processing. But what if in your fab, you could take the outcome of lots going through your fab, you could say, I know from my electrical test, I have failure data, defects, and I have speed bins and parametric data for transistors or for memory. And what if at every step in the run card, I could throw in all my information, all my metrology, all my defect inspection, all the sensor data from all my CVD and PVD process tools and all that jazz and my lithography. You could predict at every point in the run card more than you knew before. What's my yield going to be on this lot, on this wafer? Could I do something to correct it parametrically? What kind of speed bins am I going to have in 4 months when this high-speed logic goes through the production line? It's really revolutionizing things like this, and people are gearing up to do these applications. There is another kind of learning where you don't have labels called unsupervised learning. And so here's a video for 40 seconds. This is a bunch of images, but we didn't tell the deep learning algorithm what the images represent. There are no labels, cat or dog. It's clustering images that it thinks somehow are similar. It doesn't understand them, but it says these different clusters are somehow similar, and we're manipulating it in a visualization tool. But so the question is, did it do its job? Did it find things that were similar? Let's look at this cluster. Oh, it's military aircraft. It didn't know that. That's called unsupervised learning. And so you can also do that semantically with language. You can take documents and it will learn how different words cluster. And without labeling their meaning, it will learn relationships. So you can look into these clusters just like in that last thing, but this was deep neural network trained on documents, something called an RNN, recurrent neural network. And look, it clustered countries, Switzerland, Mexico, Brazil. It figured out that states in the US were somehow similar. But it can do better than that. It can figure out semantic relationships and meaning. So this blew people away when this happened. I love this. So you can do something called an embedding, and it will embed the words in a lower dimensional vector space. And you can do vector addition on semantic meaning. So the high dimensional vectors that represent king, queen, man, and woman, you can take in a vector sense, just like linear algebra that we all studied. King minus man plus woman equals queen. And this just came out of it. It just learned that on its own. They were blown away when they saw this. And there's so many things like that. Let's see.